Let's recall, first of all, what is a quadrilateral? Quadrilateral is a four-sided polygon. Polygon with four sides. A parallelogram is a type of quadrilateral. It is a quadrilateral that has the following 6 characteristics. Where does the word parallelogram come from? First of all, parallel sides. The opposite sides are parallel. Those sides are parallel. Those sides are parallel. So we describe this property, this definition, by saying both pairs of opposite sides are parallel. Both pairs of opposite sides are parallel. What is another characteristic? Opposite sides are congruent. Not just opposite sides, but we say both pairs of opposite sides are congruent. What's another characteristic? Put the two together. A pair of congruent sides, and they are also parallel. So the same pair, or one pair of opposite sides, are congruent and parallel. So we combine those first two properties. Then we move to the angles. The opposite angles are congruent. So we say both pairs of opposite angles are congruent. What else about the angles? The consecutive angles, the angles next to each other, well, what has to be true about them? If this is 100 degrees, then this will be 80 degrees. They add up to 180 degrees. So we say the consecutive angles are supplementary. And not just one pair, but all of the angles that are consecutive. So also these two right next to each other. Those will also add up to 180 degrees. Any consecutive angles in the parallelogram, supplementary. And finally, about the diagonals. Well, let's draw the diagonals and get a visual to help us remember. This is what we see. The diagonals bisect each other. Diagonals bisect each other. So that's a review of a quadrilateral and the 6 properties of parallelograms. Today we get more specific into types of parallelograms. If we narrow down a parallelogram in certain ways, we get more specific types of parallelograms like the rhombus and the rectangle. Both of them are types of parallelograms. So we will say a rhombus is a parallelogram that has the following 3 things. 1, all 4 sides are congruent. So remember back to the parallelogram picture, just the opposite sides were congruent. Well, if all 4 sides are congruent, still the opposite sides are congruent, but now it's a little bit more specific. All 4 sides are congruent, then it is more specifically a rhombus. If I draw the diagonals of a rhombus, you'll notice in this picture after we draw them that they make a T-shape or a right angle. The diagonals are perpendicular in a rhombus. Diagonals are perpendicular. So you can think to yourself that means they make a 90-degree angle. Also, pertaining to the diagonals, if I draw them, notice that the way they intersect at the angles, the way they connect to the angles, is that they are bisecting the angles. This angle and this angle are congruent to each other. This angle and this angle congruent to each other. The angles are being bisected by the diagonals. Each diagonal bisect the opposite angles. The diagonals of rhombus, WXYZ, intersect at point V. Given that the measure of angle XZY equals 34 degrees, XZY, 34 degrees, and WV equals 7, WV 7, find the indicated measure. Now here's what I'm going to do first before I try to figure these out. It's a rhombus. So what do I know about a rhombus? Let's mark it in the picture. Because it's a rhombus, I think to myself, 4 congruent sides, diagonals perpendicular, and diagonals bisect angles. So I'm going to draw that in my picture. 4 congruent sides, diagonals perpendicular, and diagonals bisect angles. Those are congruent to those, and those are congruent with those. That's going to help me immensely without having to do too much work. Okay, I get to see a visual in this picture. Now remember that a rhombus is a parallelogram, so all of the parallelogram properties exist too, such as the diagonals bisect each other, that piece is congruent to that piece, and this piece is congruent to this piece. So if WV is 7, VY also 7. Let's go ahead and see what's being asked for over here. The measure of angle WZV. Here's W, down to Z, and up to V. Well, from my congruent marks, this isn't difficult. I see this is 34, and this one's supposed to be the same, so this one's also 34. Degrees, of course, because it's an angle. Let's see how we're going to figure out ZY. Where is ZY? ZY is this guy right here. Well, I know he's supposed to be congruent to the other sides, but I don't know how much the other sides are. Let's look around and maybe try to take on a shape that we know, such as this figure right here is a triangle. More specifically, because of this right angle, it is a right triangle. In fact, you may feel a little bit better drawing this separate from the picture to help it be more clear. Now remember how we said the diagonal was bisected, so if that's 7, that's also 7. Let's mark it in our picture. This down here was given as 34 degrees. Let's mark it in our picture. And ZY was the one that we wanted to know. So let's call this the one we want to know. Maybe we'll put a question mark there. Okay, if you want to call it X or something, feel free. I'm not going to use X because an X was used in the angle up here. How do I figure out this side of a right triangle when I know an angle and a side opposite from that angle? Are you thinking SOHCAHTOA? It'd be good if you were. Why SOHCAHTOA? Because I have an angle, and opposite from that angle, I have a side. What's this side called? It's across from the right angle, so it's the hypotenuse. Opposite and hypotenuse, that's going to be sine. So I set up my equation. Sine of 34 degrees equals opposite 7 over hypotenuse question mark. What do we do when the variable's in the bottom? Interchange property. Question mark equals 7 divided by the sine of 34 degrees. Now, make sure your calculator is in degree mode. 7 divided by the sine of 34 degrees is approximately 12.5. So we get about 12.5 for ZY.